Accessing the Seismic Event Catalog from the InSight mission to Mars, presented by Autumn Johnson from the IRIS Data Management Center. Data is bit streamed from Mars at a rate of 3 megabits a day and downlinked to Earth through the Deep Space Network to the computers of SysMock. The first manual data is performed by the Marsquake service, led and operated by ETH Zürich. They compile the event catalog from this raw seismic signal. They update this catalog every 3 months as a new version, and this data is distributed by IRIS and IPGP to the public. The waveform data is additionally distributed by IPGP, who also passes it on to IRIS for distribution. So already at IRIS, you can access the catalog through some super dynamic tables. It's a nice browsable view into the catalog. More recently, we have made the Mars Event Service available in IRIS services. It's an adaptation of the FDSN-WS event specification for Mars events. The current all versions of the catalog are available using the version parameter from this service. The service serves 2 data formats. By default, QuakeML is returned. This validates against QuakeML 1.2, but it also has some Mars-specific data. These elements are prefixed with the Mars namespace and contribute additional location quality, type certainty, and environmental information. By default, all origins and magnitudes are returned with the XML. You can choose to only turn the preferred by setting these include all magnitudes and include all origins to false. By default, arrival and pick information is not returned, so include arrivals can be set to true. Optionally, the service can return a text representation of the QuakeML. This is pipe-separated text and is super useful in the browser or a command line interface as it provides a readable summary of events. Only the preferred magnitudes and origins are included in the result set. You can see the first line here represents the public ID of the event. The Mars Event Service has chosen to preserve the the IDs included in the original catalog. So you can see under contributor ID, we have the event names, as this is an alternative way to identify events. While event names they persist with an event because they encode information about what type it is and what day it occurred on. The public IDs are changed when information in the event changes. So they can be used in this way to track changes across catalogs. Locating events on Mars poses unique challenges because there's only a single station observer, while on Earth we depend on a huge network of global seismometers. All events in the catalog not assigned a location or without a computed location are assigned that of the lander. In order to find the events with a location, there are 3, you can use the bounding radius method of location selection provided by the service and set the latitude and longitude equal to the location of the lander and the min radius to 1, meaning you'll select all events outside of that. The reason why why some events have locations and others don't comes down to the quality of the signal. This location quality is a type characterization of the seismic signal. It relates how strong it is and how easily MQS is able to identify phase arrivals. It's graded A to D, where D is possibly not seismic, and A quality events are ones which locations can be determined. Events are also characterized by event type, which encodes the frequency content of the seismic signal, and magnitudes are assigned magnitude types. These scales are specific to Mars and even have been updated since the landing with new data. Here's the breakdown of kind of the types and qualities of events across the current catalog. You can see in red it compares version 5's counts with version 6 counts. The service is really powerful in that all of these counts can be easily generated. You can select a comma-separated list of event types, a comma-separated list of location qualities, and choose the version. In terms of totals, there's been about 500 recorded Marsquakes. So those are the event types in the low frequency family and the high frequency family. The other event types, super high frequency events, are potentially attributed to thermal cracking, and there's been 800 of these in the catalog so far. You can kind of see the distribution of these event types and qualities over time. The quietest part of the day is in the purple spectrum, and this occurs around sunset. So this is when signals are most clear. And you can use the service to select these select events within these time bounds. The service, as well as the catalog, use times in UTC. However, you can see in this chart that times are in local Martian solar time. So one cool thing that you can do with the event catalog is integrate it with time series data. Time series, the waveform data from the mission, is also available from the IRIS DMC. You can find all of the metadata and naming conventions from our metadata aggregator here. It has more details about the different channels and frequencies available. The station code ELYSE denotes the scientific data from the surface of Mars, so that's the seismometer. And the network, the InSight network over there is XB. So you can use the information returned from the Mars Event Service as input to the time series plot service to generate a seismogram for a given event. I chose event S0173A, which was the first event identified with a location on Mars. It's also the highest magnitude event of location quality A. So it's a milestone. So you can use the service and get the start time of the event and input this into the time series plot, which accepts not only time bounds, but also identifier information at the channel level. So network, station, channel, and location information. Oops. So here's the services URL builder, and here's kind of the service interface homepage. The help docs are in the help tab, and they're quite detailed. We're going to use the URL builder to fetch the event information for the event that occurred on Sol 173. It's a high frequency event, or it's in the low frequency family. Occurred on Sol 173, and A is the unique identifier. Let's select text format, since we only need time information. There we go. So the time is the second column in the text output. It's right here. So we can plug this into a time series plot URL. You'll notice that I've already plugged in the SNCL information, but I've left the start time blank. So I'll paste that in, and this will give us the time series plot for that event. There we go. So a quick note on standards used in the service. Basically, this service is built on standards. The last time we put a seismometer on Mars was the Viking mission. And in fact, this predated a standard digital geophysical data format. Part of the reason why it was hard to get that data out to the community and access it. It wasn't until 1988 when the first internet RFC defining content types sent over the wire in a format other than US ASCII was defined. This was big, and coincidentally, or not so coincidentally, coincided with the development of SEED format, the first standard digital geophysical format. In the 2000s, QuakeML began active community development, and this was followed by the FDSN-event specification to consume and distribute QuakeML. And that kind of leaves us at the InSight mission, which at least the data here is built on all of these standards. And they will be very important in ensuring that data is accessible and easily accessible for the long term. Here's a quick note on the architecture used by the service and the back end used to hold the catalog. It uses a very efficient partitioning system, which will allow query speed to stay constant despite new catalogs being added. And it uses a Postgres backend. Here's a list of references. Here's the current catalog citation, as well as previous catalog citations. Here's the citation for the raw data and acknowledgements to my co-authors.